Hello friends, welcome back to my channel. I'm Mr. Sohen Chutke, helping you with tomorrow's ISC exam. So before we begin, first of all, a big thank you to all of you for making my video reach 1000 views for the very first time. And I got a lot of comments saying that you want some more videos on ISC conversions, especially those conversions which have been asked in the previous board exams. So I am today's video is going to be dedicated especially on conversions. So basically, what are conversions? Okay, conversions are nothing but they'll give you a starting molecule and ask you to convert it to another molecule, another organic compound. Now, meanwhile, you need to focus on what's happening in the conversion, meaning like if they are, like in this case, they are asking you to start with oxalic acid and move on to formic acid. So oxalic acid is a structure of 2 carbons and formic acid is a structure of 1 carbon. So need to convert. It's like a step down reaction. Why? Because 2 carbons are converting into 1 carbon, so you need to step down. And in these conversions, you cannot really rely only on one chapter. You have to use your knowledge from multiple chapters. And moreover, sometimes we'll also have to utilize 3 to 4 chapters together. So now when I'm starting with a very simple example, that is oxalic acid. So oxalic acid is a structure which is H2C2O4 in this format. Molecular formula is H2C2O4, and we just have to heat this to 200 to 250 degrees Celsius. This one is a simpler one, okay, to start with. So CO2 will get removed. This is decarboxylation. So you understand what I'm doing right here, okay? So decarboxylation is my way of stepping down in this particular method, okay? You can use other methods also to step down. See, conversion cannot have only one way, okay? It can have multiple ways of getting it right. So we've removed CO2 from here, and what is left is HCOOH. So that is nothing but formic acid. So hence we have converted oxalic acid to formic acid, a pretty simple one. Now we are having acetic acid to methane over here. So we need to convert acetic acid to methane. So this is the formula of acetic acid, CH3COH, and for converting it into methane, so again it's a step down reaction. So then what is a step up reaction? Like, you know, Wood's reaction, of course, right? So Wood's reaction is a step up reaction. Okay, so for those who do not know Wood's reaction, just quickly have a look over here. So in Wood's reaction, what are we having? CH3Cl plus 2Na plus ClCH3. So it's chloromethane plus chloromethane. In presence of dry ether, wherever there is sodium, you need to use dry ether. Otherwise, the reaction may explode because sodium is sensitive towards moisture. So 2Na and 2Cl will combine to form 2NaCl, and this CH3 and CH3 will combine to form ethane. Okay, combine to form ethane. You know how I remembered this structure, how I remember this reaction? It's basically on this letter W. So W is what? It is U plus U connected to form a W. So what are you teaching us? Is this English class? No, it's a chemistry class. But you know, this word W, we say WWW, but actually it is a double U. Okay, so it is a W. Over the period of time, it's become W. Okay, so it is a W. U connected with U forms a W. So similarly, you have to do the same thing. You have to form a W in this reaction. This is your U and this is another U. This U and U, connect these two U's. Okay, CH3 and CH3 you connect to form an ethane. So did you observe what I wanted to tell you? That there is a step up reaction, meaning here there was 1 carbon in the reactor and we've got 2 carbons in the product. So there is a step up reaction. That's called as a step up reaction. Similarly, now acetic acid to methane, I need to step down because here there are 2 carbons and in my product there should be 1 carbon. So what am I supposed to do? I am supposed to think about something which will allow me to step down, allow me to remove 1 carbon. And how to do that? Come on, we'll react this with a base NaOH. Okay, acids and bases react to form salt and water. All of you know that very well. Okay, so CH3COONA. Okay, acids and bases react to form salt and water. This is the salt, plus you'll get water. CH3COONA plus H2O. So basically what has happened, H and OH is combined to form H2O and Na has got attached over here. We've got sodium acetate. What have we got? Sodium acetate. Now this sodium acetate, what are we going to do is we have to further decarboxylate it because our aim is to remove 1 carbon. Okay, so we're going to heat it in presence of, we're going to, the process is called as dry distillation, and that has to be done in the presence of quicklime plus caustic soda. Quicklime plus caustic soda is nothing but sodium hydroxide. So this combination is called as soda lime. Okay, this combination is called as soda lime. Soda comes from the word caustic soda. Lime comes from the word quicklime. Soda lime. So CaO and NaOH. So CaO is going to act as the catalyst, and NaOH will now combine with this part. Now please observe this ultra carefully. Okay, what has happened? Na. I'll write over here. Na, Na2, C, O1, O2, O3. Okay, Na2CO3. Let me number it: Na1, Na2. Okay, 2Na. Then the C, first oxygen, second oxygen, and third oxygen. Na2CO3. That's what we have got. Na2CO3. Okay, and what are we left with? We are left with CH3 and H. CH3 and H will combine ultimately to form methane. So our purpose has been solved. We had to convert acetic acid to methane, and so we have converted acetic acid to methane. So this was also a simpler one, but this is the one which is you need to think a little. So this equation, in this conversion, we have to convert acetic anhydride to methylamine. So what is acetic anhydride? Acetic anhydride is formed by the dehydration of carboxylic acid. Which carboxylic acid? Acetic acid, of course. So if you take acetic acid, okay, and dehydrate it, anhydride meaning completely without water, so HNOH, if you remove, what are you going to get is nothing but acetic anhydride. Although this is not asked over here, I'm just showing you quickly for the children who are a little weak or don't know what is acetic anhydride. So this is acetic anhydride completely without water. Okay, anhydride without water. So acetic anhydride. Now this acetic anhydride, we're going to treat it with ammonia. So ammonia, please give me the liberty to write like this: HNH2. And what's going to happen is the bond is going to break from here, and this bond is going to break from here, of course. So H will get attached to this oxygen, and when H gets attached to this oxygen, what's going to happen is we are going to get CH3C double bond O NH2. And when this H gets attached over here, we get acetic acid back, CH3COOH. So just leave this acetic acid, focus on acetamide. What is this? Acetamide, CH3C double bond O NH2. Now converting this acetamide to our final structure, that is methylamine, will require stepping down. And how will we step down? We'll step down with the help of Hoffman bromamide degradation. So what is this? This is a reaction which is given in your textbook as well, Hoffman bromamide degradation. So just have a look at how I'm writing this Hoffman bromamide. Okay, Hoffman bromamide. Okay, Hoffman bromamide degradation. So Hoffman, N I have written capital because we're going to use NaOH, N for NaOH. We're going to require a couple of NaOH. We're going to require bromine. We're going to require amide. Amide we already have. Okay, amide we already have. We are going to add what? NaOH to this. What are we going to add? NaOH to this. Okay, how many NaOH are we going to add? I think we'll require 4 NaOH over here. That 2N, you can duplicate it, and remember that we're going to require a total of 4 NaOH over here, and we're going to require bromine, Br2. Okay, so now what's going to happen is 2Na and 2Br will combine to form 2NaBr. Okay, 2Na and 2Br will combine to form 2NaBr. All right, then we are also having this C double bond. So what are we going to do is Na2, have a careful look towards what we are doing. Yeah, so Na and Na will combine to form Na2. Just like in the previous case, we had combined Na2, CO1, O2, O3. So Na2CO3 will get combined over here. And finally, what are we left with? CH3 and NH2. We have removed the complete C double bond. We have decarboxylated it. We've stepped down, and CH3 and NH2 will combine to form methylamine. So that's what we wanted, methylamine, CH3 and NH2. But hey, hold on a second. We have not yet combine these HNOH. So 2H will combine with 2OH to give you 2H2O. Yeah. So this is how we can convert what? The starting product, that is acetic anhydride, initially acetic anhydride to methylamine, but first we convert acetic anhydride to acetamide. Okay, and acetamide can be easily converted into methylamine by using something called as Hoffman bromamide degradation. Degradation itself indicates that you are going to step down. Okay, you're going to break that product and you're going to step down. Now let's move on to the next part, that is acetaldehyde to acetone. Now let's convert acetaldehyde to acetone. Now how do you do this? This is your acetaldehyde. Okay, first thing what you do is convert acetaldehyde into acetic acid. How do I do that? By oxidizing it. You know it very well that acetaldehyde or aldehydes on oxidation give you carboxylic acid. Now we require a nascent oxygen for this. So from where do we get that nascent oxygen? By the combination of K2Cr2O7 and dilute H2SO4. Now what happens when you react with K2? What happens when you react K2Cr2O7 with dilute H2SO4? I'm just going in a little depth to make you understand that how nascent hydrogen is being generated. Okay, and why it is important to add this combination K2Cr2O7 and dilute H2SO4. So what is going to happen is K2 and SO4 is going to combine to form K2SO4 over here. Okay, K2 and SO4 will combine to form K2SO4. The Cr2 will combine with the remaining 3 SO4, forming Cr2SO4 thrice. So Cr2 is undergoing reduction over here. So that's the nature of oxidizing agent. They themselves undergo reduction and make the species undergo oxidation. So we are having 4 hydrogens and 7 oxygens. 4 hydrogens will combine with 4 oxygens. So out of 7, right? Out of 7 oxygens, how many oxygens are we going to require? 1, 2, 3, 4. 4 oxygens we will require and 3 oxygens will remain. So those 3 oxygens which will remain will be released as 3 nascent oxygens, and 4 oxygens will combine with the 4 hydrogens to form 4H2O. And that's how we generate these nascent oxygens. So these nascent oxygens over here, we are requiring these nascent oxygens over here. This nascent oxygen will oxidize the acetaldehyde to CH3C double bond OH. That is nothing but acetic acid. So this nascent oxygens come in between. Okay, broken the bond. This bond has been broken. Oxygen has been added. Okay, we have got acetic acid. Now, once we get acetic acid, what you do is react this acetic acid with calcium hydroxide. React this acetic acid with calcium hydroxide. Now acids, again, the reaction is acids and bases. Acids and bases react to form salt and water, no needless to say. Okay, so you take 2 moles of acetic acid so that you can combine it with to combine to form the salt with calcium. This is calcium acetate. You're forming a salt with calcium. So this is your salt with calcium. Okay, and this is calcium acetate because you are going to take 2 moles of acetic acid over here, react it with calcium hydroxide. So calcium will get attached to 2 acetate, and these 2 hydrogens will combine with these 2 OH to give you 2H2O. That's it. Okay, so here we have got calcium acetate. Now what you do is again dry distillation. Okay, perform dry distillation over here, and when you do that dry distillation, you can use CaO as well. Yeah, so when you perform the dry distillation, what's going to happen is this thing is going to combine. Okay, what is combining? Just have a look. CaCO1O2O3 CaCO3. Okay, CaCO3, and what is remaining is CH3C double bond O CH3. That's nothing but acetone. CH3C double bond O CH3. So ultimately we have converted acetaldehyde to acetone. There are other ways also of doing this reaction, but this way is the smallest one. Okay, acetaldehyde to acetone. Well, if you want any other help, please feel free to connect with me in the comment box. Thank you and happy studying, and of course all the best for your tomorrow's exam.